Alright, welcome back everybody. This could be the final instructional video. It should be for Route 7, for Section 7.4. This is called Approximating the Binomial Distribution using the normal distribution. This is the fourth, I hope, of four videos on this. And so how do you do this? Procedure. 1. You identify N and P. What is NP? 2. Once you have it identified, the mean is NP. The standard deviation is the square root of NP times 1 minus P. And we're going to use them in a Z situation. The third thing we do is called the continuity correction factor. Here's you're going to find determine X. And we're either going to add or subtract 0.5 to the X value, depending on the words. At least, at most, greater than, less than. We're adding or subtracting 0.5. This is called the continuity correction factor. It's what we discussed in the last video. Once you have X, then you're going to get is, well, draw the curve. Draw the curve. Here is the mean. This is NP. NP. If you're going to 100 here, 100 goes there. And then X is depending on greater than or less than. You're going to color it in somehow. You draw the curve. I didn't mean to draw the curve. Draw the curve. Draw, label. Draw and label the curve. And shade. Shade. 5. Then you get a Z value. Get Z. I'm trying to get so low. There's 2 more. Look up the probability. And 7th is write a sentence. Sorry about that. I hope you can see that. That's really very low. But all we're doing now is examples. I have as many as 3 of them, depending on the time consideration. Let's start like this. There's a test of 100 questions. You studied for this test. You studied for this test, and you believe that you are confident that you're going to get 90% correct. On any particular question, you're 90% confident that you're going to get any particular question correct. And so what is the probability that you take this test? Probability of getting less than 88 correct. Okay, you got the premise. There's a 100 question test. Any question you have a 90% chance of getting correct. So what is the probability of getting getting less than 88? You're going from, this is a B plus to a B, so you really want to know the probability. So here we go. What is N and P? N is 100 questions. P is 0.9. So that's 1. 2. Then mu is NP, which is 90. I'm going to talk about that in a second. Sigma is the square root of NP, which is 90, times 0.1, which is 3. And I just want to talk about this right here. The mean is 90, NP. The number of questions times the percentage of getting each question correct. Of course that's going to be 90. The mean is 90. You expect to get 90 of the 100 questions correct. So I just wanted to point that out. Let's get X. Probably getting less than 88. Less than 88. Does that include 88? I don't think so. If you're not sure, I always do this. 86, 89, 90. If you're not sure, then write a sequence of 5 numbers down with 88 being the mean in the middle, and say which ones are less than 88. Oh, those are less than 88. I'm not counting 88. So X is, I'm going down. 87.5. We use this continuity correction factor because theoretically it's impossible to get a half a question either right or wrong. Suppose they're true false, I guess. I don't know. I'll emphasize this in the next one too. We always are adding or subtracting a half from what x is. So we're there. So now we're going to draw the curve. Remember, 90. That's the expected value or the mean. Here's 87.5. By the way, let's do it like this. 90. Here's 88. Here's 87.5. We want this, less than 87.5. Notice we're not taking that little bit of area there in between the two because it's impossible to hit 87.5. This is actually a discrete distribution. It's either 86, 87, 88, 89, all the way up to 90, and on. But because we're approximating, that's a continuity correction factor. So Z, 87.5 minus 90 over, what's the standard D? 3. 1.6, whoops, which one? 0.83. That's what I got for the Z value. And then I look that up, 0.83, let's see, I make it negative here. There is a 23.3. P is 23.3. I underline those on the quiz, and then you write a sentence. There is a 20.33% probability that you got yourself a B. That you got less than 88. 88 correct. Let that sink in for a second. We're only going to get one more. Shoot. One more example. 12% of humans are lefty. When I say lefty, I'm going to use lefty. I mean left-handed. They're left-handed. Lower to left-handed. And so of 200 people, what's probability that at least 21 of them are left-handed? At least. Those are the continuity correction factor words. 21 are lefty. All right. The steps. First, what's N, what's P? N is 200 people. P is 12%. So mu is N times P, which is 24, I think. Of these 200 people, we would expect 24 of them to be left-handed because of the percentages. And then sigma, the standard deviation, is the square root of that 24 times 0.88, which I got sigma to be 4.6. Mean of 24, that's what we expect of 200 people. That's what the standard deviation is. And then x, at least 21. What are we going to let x be? 19, 20, 21, 22, 23. Where would at least 21 start? Right there. So we're going to let x be 20.5. When we say at least 21, and because these are humans, you can't have 20.5 humans. Again, the curve, there's 24. 24 is the mean, and we want at least 20.5. There's what 20.5 is. Again, that's impossible. These are discrete, but we're using this continuous distribution to approximate it. So here we go. We got that. Z value then is 20.5 minus whatever the mean is, 24 over 4.6, and I got that z value to be, this one down here, 0.76. It's negative, of course, meaning if I look it up as negative, I'd be here, but I'm just not going to look up a positive. 77.64. P then is 7764, 0. That's what I looked up. That's the answer to the problem. There is a 77.64% probability that of 200 humans, at least 21 are lefty. Okay. Yeah. Stop that craziness.